Hello, students, and welcome to the final section, part 7 of topographic maps, and we'll be going over topographic profiles. Now, all a profile is just shows a side view of an Earth surface. So when we looked at the topographic lines, we were getting a two-dimensional aerial view. So now what we're going to do is we're going to construct a side view from a two-dimensional map. Okay, and we'll look something like this. Okay, where we can see the elevation as it is steep on one side, gradual, where it peaks up to the top, where it might be a mountain. So we could configure that the topographic or contour lines would make circles since it's showing a mountain. So in order to construct a profile, you're going to mark the elevation of each contour or hatchet line on the map above the location where you'll place your scrap paper. So this is a very hands-on activity, and I'm just going to walk you through the process of the instructions and then show you a couple on a computer. And when we have class time, we will be doing this with your with maps and with some scrap paper by yourselves. So the second step is you're going to place a strip of paper along the profile line of the contour map, and this will make more sense in a bit. Make a mark on the strip of the paper wherever the paper crosses a contour line and label the marks with their value or their elevation. Next step, you're going to place a strip of paper along the edge of a grid where you're going to be drawing your profile. And then you're going to project the marks upward to locate the points on the profile. And then you're going to connect it with a smooth line connecting the points. Note that hilltops and depressions, bottoms, are not flat. The profile has to be rounded off. Okay, but we gotta make sure it doesn't get rounded off into the next contour line or below the lower contour line. And you guys this will be explained better as we go through this lesson. So, for example, you're going to construct a profile for the topographic map below. Okay, we saw this in the previous one we were talking about gradient. Okay, we saw in the gradient lesson that B would be steeper than A. So in order to do this, we're going to take a piece of scrap paper. We're going to label our contour lines first, contour lines. We're going to put a piece of paper up there at A and at B. We're going to make a mark where A is, and we're going to label that with the elevation at A. We're going to do this going across the map or across the profile, okay, to get all the identifications of the contour lines with their elevations. Once we get that, we're going to move it down to the bottom. Now you see I lined up A with A here, and B is lined up with B on the bottom. We're going to project the values of our measurements. So you see on the left-hand side here, they were spaced out a lot more than they were where we saw that it was going to be a steeper elevation. We're going to project those values up onto our graph. So we're going to see A, 0. We're going to mark above that, above 20, above 40, above 60, above 80, above 100. And then to the right side, when we're getting closer to B, we're going to put our 100 over here, 80, 60, 40, 20, and then B was at 0. So this is giving us a visual of a side perspective of the mountain based off of aerial perspective. We're going to connect this with a smooth curved line. Okay, and as we said before, we are going to round out the top. And we got to make sure that that rounded out top does not reach that 120 line. And it also doesn't flatten out at the 100 because we know it could possibly be higher. Okay, and that goes into our possible elevations lesson. It could possibly be as high as 119. Okay, but we cannot touch that 120 line. Okay, let's do another example. Okay. So the topographic map below shows a small island in an ocean. Points A, B, C, and D represent surface locations on the island. A triangulation point is shown in the highest elevation of the island, which just means that the highest point of this island could be 134 feet. Elevations are measured in feet and distances are measured in miles. On the grid on the right, construct a profile along AB by plotting a point for the elevation of each contour line that crosses line AB. Connect the points with the smooth curved line to complete the profile. So we see where A and B are on our map, okay, and we have a line that goes through. So we're going to put a piece of scrap paper, Okay, well, we're going to identify the contour lines again. So it says down here that the contour interval is 20 feet. We know the ocean is 0. So A is 20, the next one's 40, 60, 80, okay, and then it's 100, okay, and 100 is already labeled for you. Okay, 120, then 120 again, because they're going down the back side of the mountain, then it goes to 100, 80, 60, 40, and then 20 for B. So A and B are at the same elevation. We're going to put our piece of scrap paper, we're going to mark where A is, and we're going to mark down the value of that line for A. We're going to continue doing this all the way across until we get to B, and you can see I'm writing down the values on my scrap paper. Okay. Based upon this, we see that the contour lines are tighter to the north on our map, so the steeper angle would be on the northern side of this island. We're going to take our scrap paper and put it onto the profile graph that's on the right-hand side of this screen. We're going to project our values up above these points. So where A is, we're going to put a mark where 20 is right above it. 40, 60, 80, 100, 120. And then we have 120 again. And then we're going to come down steeply because you see how the contour lines are very tight on the north side. And then we're going to finish this off with a rounded curve line. Okay, making sure that our highest point doesn't go up to 140 and it also doesn't flatten out at 120. Okay, another example. Now this one shows these hatchet lines. And if you remember from our hatchet line discussion, that these show a depression, so the land is going downward. So we're going to do a profile from X to Y. Okay, we're going to label our contour lines. X is 10. Next line is going to be 20. Remember, the outside hatchet line is going to match the outside contour line, which is another 20, 10, 10 again because it's the same line, 20, 30, 40, 40 again, 30 again, and then 20 for Y. Now notice how X and Y do not start and end at the same elevation. Okay, and on our profile map on the right-hand side here, we see that Y is higher than X. Okay, so that's a good check on for us. We're going to put our piece of paper up there, mark our locations for X, and the value of the elevation for each one of these contour lines that our piece of paper comes in contact with as we go across the page. Okay, once we have that done, we will bring our scrap paper over to the graph, and we will project upward these elevations. So X and Y are already done for us. So we have our 20, another again 20, 10, 10, 20, 30, 40, 40, 30, and 20. Now we knew that between the two 10s, there was a depression, so we were going to go down with our smooth curve line. And then when we saw between the 40s here, it was going to be a hilltop, so we went a little above, but we didn't touch that 50-foot line. Okay, another example. Now we're going to be doing from A to B. We're going to start off, this is the ocean, so our contour line at the ocean is 0, and our contour interval is 50, 100, 150, 200, 250, 300, 300 again, 250, and all the way back down towards 0, which is B. Now, if you notice here in this middle section, I'm going to back it up a bit, we went downhill to 150. Now, 150 was on the other side here, and then it starts going back up again. So we're going to see how that looks like in our profile. We're going to put our piece of scrap paper here. We're going to mark each one of our lines with where it comes in contact with a contour line with the elevation that's assigned. And we're going to do this across the whole entire page. Okay, and then we're going to move our scrap paper over to our graph. And then we're going to project the values above. So we had 0 already done for us, 50, 100, 150, 200, 250, 300, 300 again. And then we go back down to 150. And then we have 150 again on the other side. We go back up to 200 and then back down until we get to 0 at B. So we saw that there was a decline between these two hilltops.